Here's a refresher on long division. So if I want to calculate 125 divided by 4, I can set it up by doing 125 divided by 4. Alright, now here's the first part where you have to be careful not to write the number in the wrong spot. The dividend, which is 125, should be here underneath the division bracket, and the divisor, which is 4, needs to be on the outside. Okay, after I set this up, I can go ahead and just go down the list of numbers and see how many times the divisor can go into it. Alright, so the first number is 1. 4 cannot go into 1 because 4 is bigger than 1, with the exception of if I multiply it by 0, because 0 times 4 will give me a 0, and then I'm able to have 1 remain after that. Right, and then I move on to the next number by pulling it down. Together I have 12. So 4 can go into 12 3 times, because 3 times 4 is 12. Alright, I am left with the 0, but after I pull down the 5, now I have 5. Alright, 4 can go into 5 one time without going over. Alright, because 1 times 4 is 4, and that'll leave me with a 1. Now, I still have a remainder left, so that means I can keep going. Right, but starting from here, I will need to make sure I have a decimal, because 125, if I'm going to keep on pulling numbers, I can. I'm going to extend this a little bit, right? Because I can pull down to 0, but I need to make sure that I separate it with a decimal, because if I don't, I'm actually adding a 0 and making it 1,250, and that's not allowed because I'm actually changing the number, right? By adding a 0 after a decimal, I'm not actually changing the number. This is still 125.0 is still 125, right? And then that means in my answer, that is also where the decimal should be located, okay? So the reason why I did that, so I can pull it down and continue my long division process. All right, 4 can go into 10 2 times. So 2 times 4 is 8. I'm left with the 2, and then I continue to pull down zeros, hoping that eventually it will stop. And fortunately, 5 times 4, 20. Left with the 0 for a remainder, and that means I'm done. The answer is 31.25. Now you don't have to draw these arrows, but it's just a good idea, especially if you have messy handwriting or you don't really write straight. That just helps keep all the digits lined up. Because if you start slanting or crossing over into a different lane, then that would mess up the place values, right? And then obviously that will affect the answer. This problem's relatively easy because the divisor 4 is a number that we have the times table memorized already. So when we're trying to figure out if it can go into 12, 5, 10, and 20, it's within our memorization range. Right? Now, for a problem like this one, 210 divided by 42, it's going to be a little tougher because I'm pretty sure no one has their times table memorized for the number 42. Right? So to find the factors for 42, we can't just get it off of the top of our heads. We would need to figure it out with other methods. Right? So let me set this up first. 210 divided by 42. Okay, now the easiest or the simplest method, which is probably also the longest method, is this skip counting. All right, I simply list out the factors in sequential order. So the first one, 42, all right, second one, if I add 42 to 42, because that's what skip counting means, that means I'm adding 42 each time. Okay, I would get 84. Okay, so, and it would probably be a good idea to kind of label it. That's the first time, that's the second time. Okay, we can keep on going, so let's go on and go a third time, add 42 again, we would get 126, right? So that's my third time. All right, fourth time, 168. All right, now getting close, but not quite there yet. So let's go one more time to see if we can get there without going over. All right, so my fifth time, if you skip count the fifth time, you would get 210, and fortunately, that is the number we need. Okay, and then I already know that 5 times 42 equals 210, because if I add 42 5 times, it's 210. If you want to, you can also work it out on the side just to double check. All right, but that will leave us with a 0 for the remainder, which means 5 is our final answer. Okay, now again, this method is the simplest method, but it could take some time depending on the number you're using. Okay, and you don't have to organize it this way. All right, you can skip count however way you want to. This is just a really easy way to, one, work it out, show your work, and two, kind of keep track of everything. It's just nice and neat. All right, now a faster way would be to use multiplication. All right, so try to imagine a blank problem again. All right, trying to figure out what times 42 equals 210. All right, now this is a little bit of guessing is going to be involved, or you can kind of use estimation skills to get to a closer number. So what I mean by estimate, you would round this number to the closest 100. So 210 is close to 200. 42 is close to 40. So 200 divided by 40 would be 5. Right? So it would make sense that 5 should be a pretty close answer. And I mean, we know in advance right now that 5 ends up being the answer. Okay, so let's do a different problem. Let's change it to, let's say 200 and let's go 52 divided by 42. Okay, so we have 252 divided by 42. Okay, so 252 is, let's say it's close to 200, right? Because you always want to kind of go small, because if you go big and go over, then you have to go backwards. All right, so 200 divided by 40, so it should be around 5. We know it's going to be greater than 5, but we know 5 is going to be pretty close. Okay, so then on the side, we can work out 42 times 5. That will give me 5 times 2, 0, carry the 1, 210. Okay, now 210 is not quite there at 252, so from this point on, I can just skip count from 5. All right, so again, the reason why I like to do it this way is because then I can right away just add 42 to the work I just did over here. And now we get 252, and I'll get my 252, all right? And then maybe, label it, that's the 6th time, that's 5. So 6 times 42 would give me 252, right? And that would be my answer. Now, if you rather not skip count, when you get to this step right here, you can simply just go one more up using multiplication, right? So if you're a person who prefers to multiply instead of add, then I would do it this way. Simply multiply by the next number up, then you can figure out 6 times 2, 2, 1, 6, 4, 25, right? 252 is what we need, and 6 is the factor we need. Okay, so you have a couple options. If you like adding, you can use the skip counting method. If you like to multiply, then you can use the estimation method, or a combination of both. Good, dividing with decimals, we are mostly concerned with the divisor having the decimal. If the dividend has the decimal, it doesn't really affect the process that much. And we can see a little bit better here in long division form. So if we keep this problem as is, our first step would be finding out how many times 0.8 can go into the number 2. Now that would not be fun to do, especially if you have to keep on going and then subtract find the difference and pull the next number down. You're going to have decimals everywhere. All right, so the not necessarily the simpler thing, but the easier thing to do, or the least complicated thing to do, would be to somehow turn this number into a non-decimal number. All right. Now we've learned before that by multiplying a number by 10, you increase the place of that number. Meaning, if I have a number 2, right, and I multiply by 10, now I get 20. All right, so it used to be in the 1 spot, now it's in the 10 spot. Okay, and if I multiply that number by 10 again, it's now in the 100 spot. Okay, so we can apply that same concept to this number, 0.8, right? Because if I multiply 0.8 by 10, I get 8. Right, so the simplest thing to do is just to move the decimal over 1 spot. Right, each time you multiply by 10, you move over the decimal 1 spot. Right, so over here, you can write it out that I'm multiplying this number by 10, or you can simply just draw a little arrow like this and say that, okay, I'm now moving the decimal from here to here. Now, this will change the answer if I don't do something over here also. Okay, by moving this number over here, this number is increasing by a factor of 10. To balance it out, so I get the proper answer up here, I need to do the same thing to this number. So I need to multiply this number by 10 also, which would have the effect of moving the decimal place over 1 spot. So my new problem becomes 272.8 divided by 8. Okay, now I still have a decimal in this problem, but it's in the dividend, and that doesn't concern us because you saw in the previous problem that just means that my answer also has a decimal place right there. Okay, now technically you can continue to multiply both sides by 10 and then this will go away, but that will actually make the problem more difficult because now you would have 2,728 divided by 80, right? And that is definitely not as easy as this problem right here. Okay, so now that we got rid of the decimal in the divisor, we can go ahead and just work it out like it's a regular division problem, right? So I would have 0 here. Three, four, and 1. All right, so my answer would be 34.1. Okay, number 4. We have 0.34 minus negative 0.5. Alright, so first, anytime we're dealing with negative numbers, we don't really want to subtract, we want to turn it into an addition problem. So we can turn every subtraction problem into an addition problem by adding the opposite. So 0.34, instead of subtract, we add. And the opposite of negative 0.5 is positive 0.5. All right. Now, some people can do this in their head. If not, you would need to work it out on the side. Now, by adding decimals, the key or the thing you have to be careful of is to line up the decimal points. All right. Now it's not so much that the decimal points got to line up. It's more the number places have to line up, right? Because this 5, if I were to line it up over here, then I'm adding to this 4. Now this 5 really is not a 5, this 5 is a 0.5. This 4 is a 0.04, right? So if you can see clear over here, And if I were to add that, right? So 0.04 adding to 0.5, adding these two together would cause trouble because they are not in the same numbers place, right? This 5 should be lined up with the 0 over here because both of these are in the 10th place. The 4 is in the 100th place, okay? So by lining up the decimal, you automatically line up all the rest of the numbers, right? And this, by adding 0, sometimes helps people visualize it a little better, where there's actually a spot there. It's the number 0, that's why it's not there. Okay, so now we can go ahead and add the numbers. 4 plus 0 is 4, 3 plus 5 is 8. There's my decimal, so my answer is 0.84. Okay, number 8. We have negative 0.4 times 0.2. Okay. Now, first thing I want to note is I am multiplying a negative number and a positive number. So anytime we are multiplying two numbers with different signs, the answer should be negative. So maybe I can just make a note that answer should be negative. All right, so whatever I get, if it's a positive, I want to at least turn it into a negative number. All right, now to find this out, let's go ahead and work it out. 0.4, 0.2. I don't really need to write the sign because I know that the number will become negative. All right, now this is just coincidence that by lining up these two numbers, the decimals lined up. Now, if the decimals didn't line up, it would not matter like it did over here with addition because I'm not adding the numbers together. Okay. After we get our answer, there's one more step that will ensure that the decimals will end up in the right spot in the answer. Okay, we'll get to that. All right, so right now I just solve it just like any other multiplication problem. So 2 will multiply by the first number I see, which is 4, so I get 8. All right, 2 times 0 is 0. Next I got 0 times 4, but I would write it over here, okay, because this 0 is in the 1 spot, right, not in the 10th spot. Okay, so then 0, 4, 0, 0, give me 0. And go on and subtract 8 minus, if you want to visually make it easier to see, write a 0 there. 8 minus 0 is 8, and then I got zeros down that way. All right, I'm going to just write it out because I'm going to need it, because my last step is to see how many decimal spots the problem has. There's 1, there's 2, so that means my answer also needs to have 1 and 2 decimal places. Okay, and that's why it doesn't really matter if you line it up or not, because let's say I shift this whole number over 1, right? So I have 0.4 times 0.2, I'm going to fill in a 0, just fill in that spot. Okay, so the decimal places aren't lined up, but if I work everything out, get 0, 8, 0, 0, right? There's 1, 2, 3 spots. 1, 2, 3. I get the same answer, 0.08. Okay, so for some reason, if it doesn't line up, as long as you work it out properly, you take into account that extra space there, the answer will work itself out. Okay, so the answer is 0.08. Alright, so a little different than adding. When you add, you have to line up the decimal point. When you multiply, if it lines up, cool. If it doesn't, not a big deal. You just want to line up the last 2 digits. Right now over here, even though we can get the same answer, you don't really want to add an extra 0 because that actually adds an extra step there. Anytime you have an extra step, that's more chances of making a mistake. Okay, number 18, we have an algebraic equation, right? And it's a 2-step equation, meaning there are 2 things happening to the variable x, right? We don't know what x is and we want to solve for it, right? So we basically want to isolate x because that would be the easiest way to know what x is when x equals whatever is on the other side of the equation. All right, so we have to decide, what do we cancel out first? Do we cancel out the multiply by 0.07 or do we cancel out the increase by 4? All right, now the order does matter because it's related to the order of operations. 0.07 is, x is being multiplied by 0.07 first. Then it's being increased by 4. Okay, and because of that, if we were to undo that process, we would need to undo what is happening to x last. So increase by 4 is happening last. We would need to cancel out that effect first. Right? It's like putting on clothes. If you put on a shirt, then a jacket, if you were to undo that process, you would need to take the jacket off first before you can take the shirt off. Okay, so to undo increase by 4, I would decrease by 4, which is subtract 4. All right, so I'll go ahead and subtract 4 on this side of the equation, and anything I do on that side, I would need to do the same thing on this side. All right, and this will cause these two to cancel out, and then I'm left with 0.07 times x equals 32 minus 4 is 28. Okay, and then now I'm left with a one-step algebraic expression equation. Okay, to cancel out the multiplied by 0.07, I would need to divide by 0.07. Okay, and then same thing needs to happen on this side. Right, these will cancel out, and then I'm left with the x equals, now I don't know, I can't do this in my head, so I'm going to go ahead and use long division. 28, 0.07. Okay, now we don't like decimals in our divisor, so let's go ahead and multiply both sides by 100 because I want to move my decimal place over 2 spots. All right, so the 0.07 will become a 7. All right, and if I do that there, I would need to do the same thing over here. The decimal place is originally here, move it over 2 spots. Now it's here, and I need to fill in zeros for those empty spots. So my new problem is 2800 divided by 7. All right, and now I can go ahead and work it out. All right, 4 times 7 will give me the 28. All right, bring down the 0, 0, bring down the last 0, 400 is my answer. All right, and a good idea would be to plug the 400 into the x over here in the original equation and see if it comes out to 32. Okay, number 11. Sylvia bought 14 bananas at $0.11 per banana. How much did the bananas cost? All right. So first thing you want to do is to identify the important information. All right. We have 14, 0.11. All right. 14 is number of bananas. 0.11 is the cost per banana. All right. So that's the information given to us, and we are supposed to find out how much did the bananas cost. So the total cost, right? And let's go and assign that to a variable. So C for cost, and that is the total cost of bananas. Okay, now from this we should be able to come up with an equation and solve for C, and that will get us the answer that we want. Now that's where most of the students have trouble with, is coming up with the equation. Now that they struggle with it because we're trying to go from words to numbers. So let's slow down a little bit. Let's just use words and create an equation using words. Okay, so anytime I hear the word total, all right, that should kind of give me a hint that that's probably by itself. Okay, anytime we're trying to find a total, either we're adding a bunch of numbers and we get a total, or we have, something costs $5 and I buy 20 of it, what's the total cost? And you're multiplying and then you get a total. Either way, the total should be by itself. So if I have an equation and I can write total on either side, but once I pick a side, there shouldn't be anything else with it. Okay, it should be by itself. That means the remaining two things, number of bananas and cost per banana, probably has something to do with each other. Okay, they're either multiplying by each other, added to together, being subtracted from each other. Whatever the case is, it's not going to affect the total. Okay, that much I know. Okay, so what would make sense to give us a total? Well, I have number of bananas and then cost per banana. Okay, meaning if I buy one banana, it would cost 0.11. If I buy 2 bananas, it would cost 0.22, twice that amount. Okay, so that means I should be multiplying. So the cost per banana multiplied by number of bananas will give me the total cost. Okay, and maybe just there we go, total cost. Okay, now that we have our equation in word form, we can go back and substitute the numbers in. Okay, do we have something that represents the cost of per banana? Yes, we do. It's 0.11. All right, so substitute that in. Now, do we have something that represents the number of bananas? Yes, the number 14. All right. And then last, do we have something that represents the total cost? We do, even though it's not a number, but we define it as the variable c. So instead of writing that, I'm just going to write c. So then the equation we get is 0.11 times 14. That'll give me c. Okay. And then now I just solve for c. In this case, I don't actually have to solve it. I simply just have to evaluate this expression right here, and then I'll get my c. Okay, so let's go and work it out. 0.11 times 14. All right, and if you prefer, you can flip it, right? Because of the commutative property, you can do either one of these. Okay, in this case, this would probably be the easier one. I mean, actually both would be easy, but this one slightly, because both these numbers are 1, that is easy to multiply and get my answer. All right, so then we add them up, account for the number of decimal places. There's 2, so that means I need to have 2 in my answer. Okay, and just to show that it's the same, you can do the same thing over here. 4 times 1 is 4, 4, 1, 4, and then I got 1, 1. All right, 4, 5, 1, 2 decimal places, decimal place right there. All right, 1.54 for both. Okay, so that means 1.54 equals c. All right, and C is the total cost. Oops. C is the total cost of bananas, meaning we need our units to be dollars, and that is our answer. Now, this seems like a long process to solve a relatively easy question, and that's the thing. If you can see the equation pretty easily, then you don't need to go through all these steps. Okay, this is for the people who can't see the equation so quickly. They can't see it right away. The reason is because they're having trouble relating the words or translating the words into the numbers. Right? Maybe they're usually rushing and just paying attention to the numbers and trying to put them into an equation. Well, you need to know what the numbers mean before you can arrange where they go, right? And the words will make more sense because we use words every day. That's how we think. We think with words, right? The voices in your head. Those are all words. That's usually a much better way to come up with the equation, right? And if you notice, I don't have the actual problem in front of me. I just have the most important information, which is the numbers and what the numbers represent, right? That way, because another thing that wastes time is keep on going back to the problem. Like they think they don't understand it or not sure what they're asking for, and just keep on rereading the problem over and over again, right? By doing this step right here, right, just isolating the important information and writing down what you're trying to find, right? Remember, we define C with what we're trying to find. We're trying to find the total cost of the bananas, and then that way we no longer need the actual problem. We can just focus on the important information, right? And then you focus on the terms, what the numbers represent, right? And that usually will help you get the equation a little better. And then you just substitute in the numbers where they go, and then you would get your equation. And then it just becomes a normal solving for X or solving for whatever variable problem.